Hello, ninth graders. So we are starting our very last unit of the year, which is kind of crazy. I hope that you've taken the time to look at the agenda. If you have not, go ahead and do so now. That the rest of the year is planned out, so it's all out on your daily agenda already about how many days we're spending on certain things and what we're going to be learning on those days. The links aren't all there, but at least you'll have a general idea of the outline of the rest of the year and what that's going to look like, and you can prepare accordingly. Okay, so let's move on to today. Today, we're just talking about the fundamental counting principle. That's it. So here's an example that I made. Nintendo 64 Super Smash Bros. Has 12 different character options. You and 3 of your friends have decided to play together. How many different possibilities exist for the 4 of you to play? So if I were to try and take this and figure out what are all of the different possibilities. If I don't understand how to go about a problem, I tend to try and start making sense of the problem by making it tangible, making it something that I can understand. So maybe I would just want to talk about 2 characters or 2 players. Maybe it was just me and one other friend, and I wanted to figure out, well, how many different permutations, or not permutations, but possibilities exist, given we had 6 characters instead of 12, because 4 and 12, that's some big numbers. So let's try and make it some smaller numbers so we can kind of understand what's going on here. So let's say that we chose Mario as the first character. Mario. Now, that could be the first character, and then the second one could also be Mario. With Super Smash Bros., you could have everybody be Mario if you wanted to. Well, so I could do Mario and Mario, or I could do Mario and Luigi, or I could do Mario and Donkey Kong, or I could do Mario and let's do Link, Luigi. Or I could do Mario and Samus, or I could do Mario and Captain Falcon. So just using one character in one slot and going through the 6 other options, that has provided me with 6 options for those characters. Now I could go through and do it as like, okay, well then I could do Luigi and Luigi, or I could do Luigi and Donkey Kong, or I could do Luigi and Link. And then I go through all of those and figure out, well, which ones are going to work here. So the pattern that works, I'm not doing a very good job of explaining this, but the pattern that works here is that you end up multiplying all of the numbers together. So if I have 12 options for each of these guys, we would then do 12 times 12 times 12 times 12. I was just thinking for a second that what if I did Luigi and Mario, and then Mario and Luigi, and are those the same? And they are not the same. So I was wondering if I needed to subtract out the ones that I'm counting again as being the same, but I do not. Because if I, as a person, have chosen Mario and my friend has chosen Luigi, then my friend choosing Mario and me choosing Luigi are a different situation. So we don't need to subtract out repeats in this situation. I don't think we'll have any situations in these notes where we would have to subtract out repeats, but it is something to think about of like, would Mario and Luigi or Luigi and then Mario be the same thing? And in this case, it is not. So that is good. So 12 times 12 times 12 times 12 is 144 times 144. Which is 20,736 possibilities. That is a lot of possibilities. So the fundamental counting principle is the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So that's what I was trying to show you up here at the very beginning of having one character decided with 6 characters options on the left, then moving on to like Luigi as the decided character would add another 6 options. And then having Donkey Kong as the decided character would be another 6 options. And so then if we're doing that 3 times 6, so the possibilities grow and grow and grow. So you have to think about every character and every iteration of that one character with all of the other characters. And that's where this idea of the multiplication comes in. Okay, Gabriele's Wi-Fi is 10 characters in length, all of which are lowercase letters. How many different possibilities exist? Well, if it's just lowercase letters, which I'm sure we've all made passwords before, and passwords try and persuade you to do multiple like uppercase and lowercase and numbers and symbols, right? And that's because the more options you add, the higher number that we're going to get here is, which means if you've got a computer that's trying to hack into, you've got a program that you've made that's trying to, or somebody else has made that's trying to hack into whatever password protected thing you're talking about, the more possibilities exist, the harder it is for that computer to pinpoint or find out what that password is by chance. But if we have 10 characters and they're all lowercase letters, we've got 26 letters in the alphabet. So that'd be 26 times 26 times 26, 10 times. So that would be 26 to the 10th power. Okay, so remember that when your calculator has an E in the answer, that means it's scientific notation, right? So mine says 1.41. E14 means times 10 to the 14th power. So that's a lot of numbers. I can scroll up on that number and press enter to bring it down. And sometimes it will tell me all the digits. And here, this one is still too much for it to tell me all of the digits. So we'll leave it in scientific notation. Okay, so they're not always going to be straightforward like this. You do have to think about every slot that occurs and what are the options for each slot. So an Italian license plate consists of 7 characters, 2 capital letters at the beginning, followed by 3 numbers, digits, followed by 2 more capital letters. Miss Gallagher is growing tomatoes in a community garden. One day she noticed that her tomatoes had been stolen. Miss Gallagher is attempting to catch the perpetrators by identifying the license plate on the car that she saw speed away from the crime scene. She saw that the first letter was a B and the last number was not a 0, and the last letter was a vowel, not a Y. How many license plate possibilities exist? Somebody's alarm is going off. So we've got our 2 capital letters at the beginning, and then our 3 numbers, and then our 2 capital letters at the end. So we know that the first one is a B. So the only number of possibilities there is 1. There's only 1 possibility for that guy, and that's done for. And it says that the last number was not a 0. So the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 digits. If it's not a 0, that eliminates 1 possibility. So there's 9 possibilities for this slot. But that means that there's 10 possibilities here. Oh, the second capital letter has 26 options. And then we have 26 options for this, the third capital letter, but then it says that the last letter was a vowel, A, E, I, O, U. So that's 5 options. And those are all the options for each of the slots that we have of this license plate. So we take all of our options and multiply them all together. So 1 times 26 times 10 times 10 times, 1 times 26 times 10 times 10 times 9 times 26 times 5. Again, scientific notation. If I scroll up and press enter, though, it does give it to me not in scientific notation, which is, for me, what I want in this situation. 42,000 is the answer. That's how many possibilities exist. That's a lot of possibilities. But it does narrow it down from having to multiply that number again by 26 and then by another 5, pretty much. So it's smaller than it could have been, but it's still a pretty big number. Okay. For Mother's Day, my family and I played a game of Clue. At the beginning of the game, I was dealt 3 cards: the conservatory, the dining room, and Mrs. White. For those of you who don't know Clue, it's a board game where you have to guess the culprit along with what room they were in, because they murdered somebody. So you have to figure out who did the murder and what room they were in and what weapon they used. And it's a game that my family and I played all the time when I was little. Okay, so there are a total of 6 characters, 6 weapons, and 9 rooms. Well, if I need to guess the person and the weapon and the room, I know that there's a total of 6 options for the character, but I have one of those characters, which means there's really actually only 5 options. If I have the card Mrs. White, it means that that card is not in the guilty pile, and there's only 1 character card in the guilty pile. So if I have that card, that means that that person is not guilty. So I know, okay, well, I've saved 1 person from not being guilty, but there's still 5 other characters that could potentially be guilty. And then the weapons, if there's 6 weapons, I don't have any cards that have weapons. So all 6 options are still a possibility for the weapon of choice. And then if there are 9 rooms, but I have 2 of the rooms, that means that 7 other rooms could potentially be where this person was murdered. So if those are all of the options for each, or the number of options for each of the slots, that means I just need to multiply those numbers together. 5 times 6 times 7, and that is 210 possibilities. Okay, that is all you need to learn for today, the fundamental counting principle. It's when we have certain slots that you need to be filling in, and there's options for each of those slots. And then you just multiply all of those options together. We will be moving on to permutations the next class, and by the end of the week, for some of you, / beginning of next week, for the others of you, we'll be talking about combinations, which is slightly different. Okay, you'll have your homework and your exit ticket up and ready for you to go.